everyone. Welcome to my office. My name is Bailey Klusny, and I'm president of Strongside Technologies. We're a small consulting company based in Western Canada, and today we're going to talk about a project worked on about developing a reusable system for modeling equipment investment payback period. So this was an interesting project, a little bit different than most simulation projects I've worked on in the past. Usually it's, you find yourself wrestling with a big complex problem and figuring out how to model that. In this situation, it was a little bit different. So we had a bit of the opposite approach, and we had a relatively small problem or a bite-sized problem, and we're really looking to solve it, over and over and over again. So anyways, this is my presentation, and I hope you enjoy it. Thanks. So as I mentioned, this project is about developing a reusable system for modeling equipment investment paybacks. So the client for this project we're unfortunately unable to name, but they're a technology services group that exists within a really big company. So they manufacture all kinds of different things in plants all around the world, and they have quite a wide range of SKUs that they build. The team that we were working with is in charge of essentially, manufacturing technology and looking to improve manufacturing processes across the company. In general, the team is pretty busy, so that's part of where this work came out of. Some background about the project. So how this got started was there were several sites that were contacting the group, and there was getting some common requests about investing in this new type of equipment. Unfortunately, it didn't make sense to make that investment in all the situations. So the group was often tasked with modeling the system, seeing if it in that situation if there's an adequate payback, and then would get back to the site and say, yeah, you should do it, or maybe not this time. So the client wanted a solution that they could use to model the payback period of these investments anywhere in their network. So we were looking for something that was going to be reusable and replicatable without too much effort. In general, the overall objectives we had for the work was, number one was to expand access to simulation analysis across the whole organization. It was a bit of a pinch point because the team has, somewhat limited resources, so we really wanted to expand their reach. As part of this, we were interested to see if there's a way that we could host simulations on their internal network. So that was kind of the way to get there. And then, the most specific objective was to create this tool that we could reuse for assessing these investments into this particular type of equipment. At first, to be perfectly honest, this work was pretty exploratory. We didn't know if it was going to work or if we would even be able to do it. But we thought it was worth trying, so we tried. And the first thing that we wanted to look at is, what does this thing need to do, and what's the use case for this type of a system. And through that, we found that we really want to have plant personnel being able to access the system, and if they could do it through an internal website, that would be an ideal arrangement, since a lot of the site locations don't have access to Simio, or they don't always have great computers to run analyses with. And we also needed to think, okay, well, how does this system need to exist, and what are the constraints around it? So with that in mind, we got started, and started building a proof of concept. And at the end of the day, what we realized is this would make most sense if we could have a model hosted on an internal web page that could remotely run a Simio model, and generate the results accordingly. So after doing some thinking and planning on how we'd be able to pull this off, we came up with a model design for the Simio model that was, used data generated modeling pretty heavily and connected to external data source. So essentially all the key resources and the working parameters that defined, the workload and the system were all defined in a set of 5 tables. And these were all essentially, you could fill in these tables and that would define your system, and then you can run the model from that. In order to make this all work, we had to, take advantage of the Simio API. Full disclosure, I'm not really a programmer, so I worked with somebody I knew on this, and they were handling a lot of the coding, and I was handling the simulation end of things. So that worked okay in some ways, but in other ways, it would be really helpful if to have both of those skill sets would make things a lot more smooth. Anyways, that's one of the lessons learned. So for on the API side of things, our first job was to see if we could build an application that can remotely run a Simio model. And so through the API, there's the Simio Project Factory is the piece of the API that we used for that. And we were able to, after some trial and error, we were able to get it up and running and to remotely run our model, and then pull the results from the Simio experiment and write them to an external file so that we could prove to ourselves that, okay, we can have a Simio model live somewhere, run it remotely through code, and then pull the results somewhere else. And so, at the end of the day, we were pretty happy that it all worked. So took us a little while to get to there, but we did, and that was step one. So from here, then we knew, okay, well now we know that it could work. So how do we make this thing a little bit more usable? So the first thing that we had to do next is to go back and kind of refine the use case, make sure we understood, how people would be accessing this thing, and what kind of information we're going to need to make it work, and to make it an actual usable analysis. So we did some more thinking with our internal team and the client team, and worked on this a little bit more, and designing how the interface needed to flow and what data needed to be included in that interface. For us, the interface was really the key to this thing, because it helped the users define what their system looked like. And in order to make it all coherent, the data needed to be entered in a certain series of steps or a certain sequence, so that subsequent steps relied on data that was provided in some of the earlier ones. So we just had to carefully think through how we were going to collect this data. And so we put a lot of thought and work with on our side and the client side to make sure that we were gathering the right kind of information. And then we also had to plan for how this was going to work in the real live system. So when we move this off our safe environments on our own computers and move it onto the server, that's going to be a whole new level of complexity. So just starting to think about that as well. Once we got all the details sorted out, we moved on to more detailed development. From here, this was a lot of focus was on the building the user interface again, setting it up so that how are people going to access this. So we decided that, well, there's potential that users are going to want to come back over and over again and run a few different scenarios, see how they all play out. So we created the ability for users to add new projects, and then the data from each of those projects would be kept on the server or in a database and could be accessed again and rerun, changing parameters where they thought it was appropriate. Again, building up the interface, making sure that we have all the data that we need to populate the tables, and then pushing that data to the data that was collected from the interface to the database. From the database, then we had another data handling problem where we needed to convert from, the information that was collected from the users of the system and convert that into a essentially Simio data table. So just some data handling and manipulation to make sure that the fields were going in the right format so that the Simio model could read it. Um, then creating those data tables that Simio can then read in. Part of that, after once the interface was sorted out, we were also built up the simulation logic, just making sure that we've got all the output statistics that we needed to get the payback calculations, and also figuring out a way to run sort of a standardized A/B analysis of current state, future state, so that the user runs the model once and they can get that result that gives them the output. So that's what we were doing in the development phase of things, and yeah, just working on expanding things, building up, making the model and the data systems just a little bit more robust. And once we got our test model, essentially we've got the interface built, we've got the model scaled up, all the data connections were, on the surface, they look like they're all working. So then we needed to really get our hands dirty and do some more detailed testing. To do this, we set up a local host environment on each of our computers. And so we had all the system files on there, so we could, run some pre-built test scenarios where we knew what the results should be, and making sure that, when we entered those parameters into via the interface, that it would match, when it goes into the Simio model, things matched what we expected them to. The next step of that is validating the analysis against the some external calculations. So based on the numbers that the model was providing for use of the equipment and cost and all that kind of thing, checking the calculations to make sure that what we're showing as the payback period in our model is the same as what would be generated if you're going to do those calculations manually, or with a spreadsheet or something like that. So again, took us a little while to make sure that everyone was happy. Adjusting the analysis based on some feedback from the client side, fine-tuning the interface to make sure that the language was consistent with internal terms and lingo and things like that. So after lots of testing, we kept working on it, and we got it up to a point where we were all pretty happy, and it was time to move to the server. This was really the biggest step now. So we had our system up and running on our own environments, and it was good. But now we needed to move it to a live server. And so, first thing we needed to do is, number one, secure a machine that could do it. Make sure that there was a computer the system could live on. And then, working with the IT team to get the internal website set up. Once all of that kind of nuts and bolts were sorted out, we moved the system files over to the server, and then began, setting up the database, connecting all the wires and the plumbing, all that kind of good stuff, and then going through the same round of testing things, fixing things, testing things, fixing things, and just, just doing more robust testing to make sure that, we know, how the system is going to behave, and that we're happy that it's going to, give us the results that we expect. Next step was to go live. So we had the system was built. We had tested it within our internal project team, and so far things were looking good. And then the next step we need to do was to introduce the site and the tool to some potential users. So we'd set up some virtual training sessions with the initial user groups, and they were, we showed them how to, go through the interface and, what needs to be done to collect some of the data. We had built in some instructions into the interface. So, while the users were going through the steps, you could, click on a little icon to say, here's what you do in this step. If I was able to show the real system, I would be showing a lot more of the, what it looks like, but unfortunately we weren't able to do that. Um, and then, making adjustments based on that user group's feedback. So again, cleaning up some of the language on the interface, refining some of the how we're collecting the data on the interface to make it a little bit more user friendly and that kind of thing. So after we got it up and running and we did some testing and it was, we got it to work. And so the system is live on their server there. There's a group of users that can access it, or at least, when we were last working on it, they were able to, run through the analysis, generate the payback, and do their calculations that way. As I said at the beginning of the presentation, this work started out as fairly exploratory. And so there was, quite a few lessons learned along the way. One of the biggest that I would say is, user experience, or, UX design is as a major factor that you can't underestimate it. I think if there's one thing that this project could have improved on, it was, having an easier to use interface. And I think, we would probably have more widespread adoption if we had an easier to use interface. That's something that we're thinking about for our next iteration. But yeah, it's definitely something that I can't stress enough is, make sure that if you're going to build a system like this, that you make it as easy as possible on the users. Like I said, I'm not really a software or a coder that much, but I'm sure some of you out there are, and you probably would know this. Other things to think about is input validation. We want to make it hard for people to make mistakes. And when mistakes happen, by default, the API tools didn't really have much error reporting, so we had to make sure that we built that in. So if there was something was missing, or there was a data wasn't entered right, we were able to lead the users in the right direction, so that they could help them figure out what was where things may have gone wrong if data was entered incorrectly or something like that. Or if it's an internal system error, then let them know and lead them back to us so that we could fix the problems. Some other, I guess, more technical things would be, again, as I mentioned off the top, having some knowledge of both Simio and C# or another .NET programming language would be very helpful for the application development side of things. This is somewhere I want to kind of boost my skill set on, but I think there's a lot of potential for these types of applications. Another couple, again, more technical stuff, but there's some very fine details to make the Simio project factory work properly. One of those that we got stuck on a couple of times was on reference files. In your application folder, you need to have all the DLLs and the references to make the API project work properly. All the files need to be from that same version of Simio that your remote model file is running. So we found that it took us a while to figure that one out. So if you update your model version at any point, make sure that you're updating the DLLs as well in your application. And as well, you need to have a valid license to run the API application. So that's another thing to make sure that that you do. So that's about it for the talk. If anybody has questions, I'll be here to answer some. And yeah, thank you very much.
Well, thank you, Bailey, so much for the presentation today. We got a lot of questions on the API, and it kind of summed them a lot up.
Okay,
how did
great.
you learn about the Simio API?
Good question. I think I originally learned about it a while ago through an advanced training course that I was a part of. But from there, once we got started, getting real information about how to use it became a lot more important. So there's kind of three main places where I think you can find info. First one is the API reference guide. So if you look in the folder where Simio is installed on your computer in the in the C drive or something like that, there's an API reference guide file in there, which is really helpful. It shows all the different functions and things like that. Gives you an idea of the types of things that you can do through the API. Um, in that same application folder, there's also Visual Studio templates. So there's a Visual Studio project file in the same application folder where Simio is installed, and from that's sort of, they're coded in C sharp. So if you have Visual Studio, you can look at those and sort of browse through. They have examples that are kind of built up for you. And then the third place, which is probably has maybe the most detail, is GitHub. So Simio has a GitHub site, and if you just look up Simio LLC, they have some great resources there, and I think it's been expanded on since we were doing this work. So yeah, there's a few things out there, but yeah, I'd say probably GitHub is gonna have the most current info.
Awesome. And a lot of people were asking too about the level of engagement you receive from the client. So, can you talk about the level of engagement you receive from the client? And did you work with both technical and non-technical contacts?
Yeah, good question. We worked really closely with the internal team, the internal engineering team, and so mainly I would say we were in contact with mainly technical folks, and we're doing some working with the site personnel. I mean, I think most of the people that were involved with this project were pretty technical. So the plant personnel who were the user group for the tools, they were for the most part they were all engineers as well. So it was mainly a technical user group, but I think, from as I alluded to at the end of the talk there, I think if we would have had a little bit more conversations with the end users earlier on in the process, I think we probably could have come to a better interface design that would have streamlined things a little bit, made their life a little bit easier.
Yeah, Bailey, I was curious about that. You mentioned some of the iterations on that interface. So can you speak more about trying to gather those user requirements up front, maybe some of the challenges? For instance, I was thinking, did your contacts have past simulation experience, or did you have to do a lot of sort of coaching and recommending?
Good question. Um, the people on the internal team we were working with had simulation experience, but I think the end user group was not necessarily. So I think there was a lot more of the sort of the teaching of what the tool was about happened internally on the client side. So our main project contact that we were working with was working with the user group a lot more closely than we were. But I think, that being said, I think bringing that voice to the table at the beginning of the project, I think would have been helpful to make sure that we understand all the the just the little details that took us a few iterations to get to. But yeah.
Very good. And a related question, was the output also web-based, or how was the output consumed ultimately?
Yeah, everything was web based. So essentially, what we had, everything was run through. So from the user side, everything was just, it was a web page, and so it was coded in PHP, I believe, and they, from the beginning, they come to the beginning of the site, click onto their project that they've been working with, or could add a new project, and then work through the steps. With their project details, and at the bottom of the page, then there's a button where you can run your analysis essentially, and then depending on how you had structured the project, and how many different types of resources or implementations of the equipment that you were interested in, then the results would hit the go button, that would send the information that was programmed into the interface over to the database. Database would, format that back into the data table, send it to Simio, and then trigger the Simio experiment. After the Simio experiment ran, then it populated some output tables, which the tool then grabbed, and then we did some more calculations after that, and then displayed the results on the interface. So, we essentially clicked the button, had a little timer that, the hamster wheel going around and around for, it took in all, it took about 30 seconds to a minute, I think, to run a scenario, and then would give, payback in, number of years equivalent. So.
Yeah, it ties directly into our next question there. Folks are curious, how did you calculate that equipment payback period?
So it was essentially comparing against the cost of the current way of implementing that same task. So essentially the equipment would be used to, an alternate resource for doing a certain thing. And we know under the current state how much those things cost, and how long it takes in general for them to do the task. And then essentially what we did is we had in Simio, how we did it is we essentially ran two simultaneous scenarios, at this, on top of each other over the same system, and then looked at the performance of, scenario A versus scenario B. In the end, what we did was, export those the results, and then, do some comparisons of the response values that we got from the experiment. Some of the responses were based on, current state, some were based on the future state, and then they had a particular way of how they calculate the payback. So we just, did that afterwards, mainly based on, utilization rates of the different resources, amount of time spent on the current state, from the current state, how much time was spent on that, particular task, and then, calculating, given the cost of the equipment and that type of thing, how much, how long is it going to take, given the, for this thing to, pay us back, I guess. And for random components, we had some historical data that we're using for the processing rates, but yeah, it was a, as I mentioned at the beginning, it was a fairly simple process. There wasn't a lot of, detailed, yeah. So there was randomized processing times, but it wasn't too much else.